The Simson line is a line containing the feet and the perpendiculars from an arbitrary point on the circumcircle of a triangle to the sides of their extensions of the triangle. Taken from Google.com. I chose the Simson line because I believe the concepts were similar to other lessons I previously learned in geometry. Regarding the creation of the Simson line, evidence suggests that the true innovator behind Simson's theorem may in fact be William Wallace. William Wallace, from 1768 to 1843, was a Scottish mathematician who was born on the 23rd of September 1768 at Dysart in Hertfordshire, where he received his school education in 1784. His family removed to Edinburgh, where he himself was set to learn the trade of bookbinder, but his taste for mathematics had already developed itself. He made such use of the leisure hours that before the age of completion of his apprenticeship, he had made considerable acquirements in geometry, algebra, and astronomy. Taken from Theodora.com. Robert Simson, 1687 to 1768, was a Scottish mathematician, the eldest son of John Simson of Kirktonhill in Ayrshire, and was born on October 14th, 1687. He was intended for the church, but the bent of his mind was toward mathematics, and when he was a prospect opened of his succeeding to the mathematical chair at the University of Glasgow, he proceeded to London for further study. After a year in London, he returned to Glasgow, and in 1711 was appointed by the university to the professorship of mathematics, an office which he retained until 1761 and died October 1st, 1768. This was from Theodora.com. This definition of the Simson line is somewhat strained, for nowhere in works of Robert Simson, 1687 to 1768, any reference was found to the line that bears his name, taken from A. Bog O. Monley. Because of these circumstances, the Simson line is sometimes referred to as the Wallace-Simpson line. For the Simson line, it is important to note that the circumcircle is the unique circle that intersects the triangle at 3 vertices and no other points. Taken from Mary Regal, page 1. Not to mention that the Simson line is the line containing feet P1, P2, and P3 of the perpendiculars from an arbitrary point P on the circumcircle of a triangle to the sides of their extensions of the triangle. Taken from MathWorld, Wolfram.com. The Simson line theorem also varies depending on the given triangle. For example, given a triangle 4ABC and point P on its circumcircle, the feet X, Y, and Z of the perpendiculars drop from P to the lines BC, AC and AB, respectively, are collinear. Taken from Mary Regal, page 1. And when the Simpson line is dealing with the 9-point circle, the Simpson line bisects the line HP, where H is the orthocenter. Taken from Hansberger, 1995, page 46. Moreover, the midpoint of HP lies on the 9-point circle. Taken from Hansberger, 1995, pages 46 to 47. The Simpson line of two opposite points on the circumcenter of a triangle are perpendicular and meet on the 9-point circle. The angle between the Simpson lines of 2 points is half the angle of the arc. The Simpson line of any polygon vertex is the altitude through the polygon vertex, that polygon vertex. The Simpson line of a point opposite to a polygon vertex is a corresponding side. For example, if T1, T2, T3 is the Simpson line of a point T of the circle, then the triangles are directly similar, which are TT, 1T, and 2, as well as TA, 2A, and 1, taken from mathworld.wolfram. The envelope and the deltoid also play important parts for the line, since the envelope of the Simpson line of a triangle is a deltoid. Butchart, 1939, Wells, 1991, pages 155 and 230. The area of the deltoid is half the area of the circumcircle, taken from Wells, 1991, page 230. And the first Morley triangle of the starting triangle has the same orientation as the deltoid. Taken from mathworld.wolfram.com. In addition, each side of the triangle is tangent to the deltoid at a point whose distance from the midpoint of the side equals the chord of the 9-point circle cut off by that side. Taken from Wells, 1991, page 231. If a line L is the Simpson line of point P on the circumcircle of a triangle, then P is called the Simpson line pole of L. Taken from Hansberger, 1995, page 128. Also from mathworld.wolfram.com. And finally, the Simpson line states the altitudes of a reference triangle are Simpson lines whose Simpson line poles are the vertices of the reference triangle. Furthermore, the sides of the reference triangle are also Simpson lines whose Simpson line poles are the reflections of the vertices of the reference triangle about its circumcenter. Note also that the non-trivial perpendicular feet from these reflective vertices intersect the sides of the reference triangle at points that are the tangents to the Steiner deltoid, taken from mathworld.wolfram.com. Besides geometry and other areas in mathematics, the Simpson line does not have much benefit or relevance in everyday life. From researching and reading up on this topic, I find that the Simpson line has concepts and teachings similar to other lessons I have originally learned in geometry. Also, the Simpson line has shown me that if concepts and teachings are similar to other lessons we covered in geometry, then I should always keep track of these previous lessons that I have learned in geometry, because they branch out farther than I think. Finally, if I decide to pick up on geometry in my later years, I will have a good background of this topic for when I do. Now for some vocabulary. The deltoid means triangular shaped, which is taken from google.com. The orthocenter is a point where all three altitudes of the triangle intersect. An altitude is a line which passes through a vertex of the triangle and is perpendicular to the opposite side, taken from google.com. A tangent is a straight line or plane that touches a curve or a curved surface at a point, taken from google.com.